Hey, we have this problem on the board from the MIT Integration B 2015. This is problem number 1 from the qualifying exam. We have the integral of cosine to the 4th x minus sine to the 4th x. What I want to do to start is let's use difference of squares on this because both these are squares. So we'll rewrite this as cosine square x plus sine square x times cosine square x minus sine square x. And the beauty of this here is actually that this piece, cosine squared times sine squared, is just 1. So we'll just cross that off. But then we can use difference of squares again on this piece right here. Okay, so then rewriting this, we'll have the integral of cosine x plus sine x times cosine x minus sine x. And then an interesting thing happens here where actually you'll notice if you look at this, if we take the derivative of this, we'll actually get this. Because if we get the derivative of sine x, it's cosine x. If we get the derivative of cosine x, it's minus sine x. So we're set up for a u substitution, where this is going to be u and all this business is going to be du. So then making our substitution, we have a really simple integral, right? We just have u, which is this, and du, which is this. And so we can integrate that using the power rule, and we're going to have u squared over 2 plus c. We can back substitute here, and we're going to be left with, let's write this carefully. So we're going to have cosine x plus sine x squared, we'll just leave it like this for the moment, over 2 plus c. Now this is a fine answer, but what I notice is in the answers to the MIT Integration B, they have the answer as a half sine of 2x. Now we could leave this, but let's see if we can actually just show, because I like these problems where we end up with a different solution, but we want to show that these are the same. So what I'm going to do is let's multiply this out, just squaring this here. We're going to have cosine square x plus sine square x. Probably see where I'm going with this. Plus 2 times sine x cosine x all over 2. But this piece right here is just 1. So let's rewrite this and kind of distribute our 2. So we're going to have 1/2 with 1 over 2 here, plus we'll cancel our 2's here, and we'll have sine x cosine x. Okay, so now I think we're in a position to finish this off. We'll notice that this half is just a constant value. So any constant value can be just absorbed in this constant c. And then let's just rewrite this. We'll rewrite this as 2 times sine x cosine x with a half in front. But there we have this identity that 2 sine x cosine x is just sine 2x. So then we'll rewrite this as half sine 2x plus c. Kind of forgot my plus c right there. And so then this is going to be the same thing as this. And so that's an answer. But as you saw, we could express the correct answer in multiple ways. So that's it. We'll stop it there. MIT Integration B, problem number 1 from 2015.